So we've just uploaded some data and we clicked explore and we're on the exploratory data analysis page. And the first thing that we see is this massively parallel landmark ensemble, but we're going to come back to that in a minute. Now, the data set that we're looking here is a mobile phone data set, and what we're trying to predict is, did somebody churn? So we can straight away see this overview which is showing, yep, we got 10 columns, 10,000 rows, a couple of numerics, a bunch of categoricals, sort of, easy stuff. And the next section is basically the data completeness, and often one of the first things that we want to understand when dealing with data is, do we have all the data that the client told us that we were going to have? We're going to try to solve this problem. So the first thing we might notice is that name is missing, and that's not really that uncommon because often they want to not give you the personally identifiable information, so you get these sort of empty fields that have been cleansed. And then when we look at this one, we can see actually this one is about 75% missing. So, here it might be, not that useful for prediction, but always, good to know. But one of the more insidious ways that data can be wrong is actually when they've got default values. So they got a lot of default values in a column. The column looks full, but actually there's not that much meaningful data in it. And actually, if we look at this marital status column, we can see that actually 88% of the time, it's left at its default value. And this is quite typical with demographic data, which is often that stuff which is really useful for making customer-based predictions. So, but then we have other columns like where we've got like the churn reason. And actually, given that this is about the fact that we've got like 96% active customers, the fact that we have, it's no problem that we have a dominant value here. So it's really sort of just something that helps you sort of at a glance start to really understand your data a bit better. Then when we dive down here, we can see that there's the column insights. Now, basically, like if we just collapse that first chart, we can see here, okay, now these are the feature importances for the most predictive features that we have here. So this is showing us which features are most predictive. This is the actual importance chart, and we can actually see here that this is basically, like 1. So basically super important, super leaks the variable really. And when we come down here, it's actually telling us that insight. So it's saying, that there is one column that's really highly predictive of the target, and that means that it's leaking the value. And the reason why this is important, why we talk about like leaking data in data science, is because often if we've got something that is just too predictive, it's not actually really available at the time that we're trying to do the prediction. Otherwise, you'd probably just have an if statement rather than a whole data science model. And when we look at this, we can see that there's this status code. So we're going to look at this sort of versus the target in a proportional way. So we can see that here that there's like 3 different codes that can happen while the customer is actually active. But then we've got these ones which are really very strongly linked. I mean, they literally leak the exact value of the reason for churn. So obviously, that's part of the status. So that's probably something that we want to remove these sort of values during some sort of feature engineering if we think that there's some value in this data. But there's not really much signal in here. It doesn't look like either. So things like we can just safely remove this variable, and we are good. Now, going back to the sort of 5 most predictive columns. So if we ignore the status code, we look at the next value down. We can see here that we're looking at a bit of sort of like an inverse log distribution. And so, we've got our sort of mean value for our signal strength is like 96.7. And then if we start to look at this versus the target, we can see that sort of there's actually like this bad service down here. Obviously, there's such a strong correlation here. So it's basically like if you've got bad signal, you're probably going to go to another provider. So it's basically all the people who are like all of their strong customers who stay. There's very few of them staying that actually don't have great signal. So that sort of makes a lot of sense. And then when we look at monthly payments, again, sort of like just looking at some of these strong predictors, we can see that, yeah, again, this is sort of showing us quite a clear story. But again, it's not quite as harsh as we saw with the average signal strength, and that's probably why it's the second most important feature. But it sort of allows us to kind of dive in, and the fact that it's ranking the most important features allows us to sort of like start in and getting to the most meaningful data first. Now, when we're also looking at this and thinking like how we can use this data, we could think of things like, well, actually, we've got store type here, and if we look at this proportionally, We can see here that there's a bit of a difference in the mix of churn reasons. So potentially we could do some features which are combining the monthly payment and the sort of store type, and because basically like the amount you pay is probably quite related to the store, so there might be some interesting feature engineering there, and that's sort of the way we start to think about the data. Now coming down here, you can see that it's recommending that we actually remove 3 columns. This is basically feature selection. Now a lot of people might be a bit hesitant about this sort of upfront feature selection before we've done modeling on a sort of like data invariant way, and we kind of cover this off with our massively parallel landmark ensemble. So that's really sort of the crux of what this ensemble is doing. That's using this combination of like lots of XGBoost, deep neural network, and linear models to try to find a sort of more robust way than the sort of standard way that you would find in sklearn to really tell us what the feature importances are, and then help us drop those features which won't add meaningful value to our data set. And we can actually look at the technical paper as well if we want to. So yes, you can just sort of like dive into that. You can see all of the comparisons versus the other approaches, basically see the results, see that basically this is actually quite a safe approach for doing feature selection up front. So we do actually include some model scores and things like that, but this is not really the page where this is about. This is just really about sort of being able for us to rank the features perfectly and do this sort of feature selection, not about getting the best model. But once we basically got that, we can say, right, well, these 3 features seem pretty safe to drop. So again, they're there for us to basically leave ticked. And then once we leave them ticked, then we can take care of those in the action summary, which we'll come on to in a minute. Now, the next section that we're going to look at is the target insights. So here we can look at the values for our target. And that's basically, we can see that there's a massively imbalanced class here with 96% active. And that basically will often lead to trouble like this in actually predicting certain classes. And so this actually is highlighted for us. So it's telling us that basically, if we had more data for the classes that it can't predict well, we could add that data. Now, sometimes you're just sampling down from a really large data set with basically certain biases in the data, and you can easily add more rows for different values. Now, in this case, there just aren't that many people that have churned for all these different reasons. And actually, since that what we want to do is we want to predict, do they churn or not, then actually we can just group the all the churn reasons into an other class as it suggests, and then we'll probably get a more predictive model. So it's basically kind of giving us a little bit of insight into how to approach that. It's also recommending F1 score as a metric, but also showing sort of like a couple of other options. Now, obviously, if you're a more expert data scientist, you're going to use your own metrics, and you can ignore that part. So now we get down to the action summary. So this is where we've sort of said, there was one that was empty value, that's the name, we'll get rid of that. There are 3 columns that are not predictive, so we'll get rid of those. And then there's basically one that's removing the target. So if we're really happy with that, we can just click, save the data. We can download that data set, or we can basically click create a model and just get straight started into the whole AutoML and that modeling process. And then just sort of on the bottom of this page as well, we've got the feedback forms. This is basically if you've got feedback about any part of the platform or anything that you'd love to be able to do, please do drop us a note there. We love to hear more. So in the next section, we're basically going to cover off how to do the feature engineering, the data cleaning. So often this is actually part of an iterative process where you kind of come in here, you see a few different insights, you change up the data a little bit, then you come back down and you think, okay, now I've done that, right, let me see how else I can change it. And then you kind of, when you get to the point where you're happy, then you go and do your model building. So come back to that in a minute.